start recording. This is for the benefit of those who are joining us via video. You should know these 1, 2, 3, 4 conversion factors for tomorrow's quiz. Memorize them. All right, and we're starting with molecules of CCl4. Those are particles. What are we asked to find at the end? We are asked to find grams, which is our mass. So we want grams. Okay, and what can we convert particles into? So if you look, you can convert particles of A into particles of B, or you can convert particles into moles. Is the particle ratio of any use here? No, because we're always dealing with CCl4. We want to know the mass of CCl4. We're starting with grams of CCl4. We will not be using the particle ratio nor the mole ratio. So we want to go from molecules. The only thing we can go to then is moles. So we're going to convert that to moles of CCl4. And from moles of CCl4, we are asked to find grams of CCl4. Which conversion factor would we use there? Molar mass. So molecules to moles, particles to moles, that's Avogadro's number. Moles to grams, that is, I'm going to just call it MM for molar mass. Okay, so we have Avogadro's number, molar mass. So we would take 4.63 times, whoops. Actually, I should start by saying I want to find the grams of CCl4, and I am starting with 4.63 times 10 to the 24 CCl4 molecules. And if you map your problem, you'll know that you need to use Avogadro's number to change from molecules to moles. So what unit do we want on the bottom? CCl4 molecules, so that's particles. Thank you. And on the top, what unit do we want? Moles, moles of CCl4. And the 1 goes with the mole. And because we're converting between particles and moles, we use Avogadro's number, which is 6.02 times 10 to the 23. And now I've run myself out of room because I wrote memorize these, so I guess I'm going to go down here and do the rest of them. Things. So now we want to convert from moles to grams. So I'm starting with moles. Where does moles have to go in my conversion factor? Has to go on the bottom. And I want to find grams of CCl4. So my grams of CCl4 go on the top. And the molar mass of carbon tetrachloride is, I don't know, I gotta add it up. 35.5 times 4, 35.5 times 4 plus 12 equals 154.0, don't forget your 0.0 grams per 1 mole, and we get 4.63 times 10 to the 24 divided by 6.02 times 10 to the 23 times 154 equals 1184.4. Except we probably don't want that many digits, do we? We have 3 significant figures here, 3 significant figures here, and 4 significant figures here. So we would want 3. So that's going to round to 1180, and our unit The molecules cancel, the moles cancel, and the only thing we're left with is grams of CCl4. Is good? Alrighty. Would anyone like to go over any other questions? Number 8? Yeah, sure. So we want to know the mass of 33 molecules of bromine. Unless you know them by heart, I would like you to write out your 4 conversion factors. Write them out. Okay, so I've really shortened this up here. We've got particle ratio, which converts particles of A to particles of B. So I've just put P for particles. Avogadro's number goes from particles of A to moles of A. Molar mass goes from moles of A to grams of A, and mole ratio goes from moles of A to moles of B. All right. What are we starting with here? We are starting with 33 molecules. Is a molecule a particle, a mole, or a gram? Particle. It is a particle. So we're starting with a particle, and we want to finish with grams. We only have 2 conversion factors that involve particles. We have the particle ratio, and we have Avogadro's number. Do we want to convert to particles of B, whatever that might be, or are we just sticking with bromine here? We're just sticking with bromine, so we don't need the particle ratio, we don't need the mole ratio. That's when we're changing between 2 different substances, okay? So now we're down to, oh, hey, I got Avogadro's number and molar mass. What can I convert molecules of bromine into? I can convert it into moles because I got particles can go to moles. And then moles, can moles go straight to grams from there? Do we have a conversion between moles and grams? Yes, we do. That would be your molar mass, which converts between moles and mass in grams. What is the formula for bromine? Br2. So what is the molar mass of Br2? Bromine itself, I think it's 79.9. Let's see if I'm right. 79.9. Okay. So the molar mass of one bromine atom is 79.9 AMU. The mass of one mole of bromine, Br, is 79.9 AMU. What is the mass of one mole of bromine molecules, Br2? It's not hard. You do it all the time. If I gave you NaCl and said, what's the molar mass, what would you do? You would add them. Now, instead of having one Na and one Cl, you have one Br and another Br. What would you do? Add them or multiply by 2. So we get 79.9 times 2, which is equal to 160 minus 0.2, which is 159.8 grams per mole. So we want to find the number of grams of Br2. And we're starting with 33 molecules of Br2. What do we want to cancel? Molecules of Br2. And we want to find moles of Br2. And I'll be honest with you, probably the best way to do these questions is to fill in the units before you put the numbers into the conversion factor. Nobody believes me. They always want to stick the numbers in first and then go with the units. But this is actually better, right? Because then you can say, what number goes with moles? 1. And what number goes with molecules, particles? 6.02 times 10 to the 23. And once again, I have not left myself enough room, but that's okay. We can do this here. Molecules have canceled. Now we're left with moles, and we want to find grams. What is the conversion factor between moles and grams? Molar mass. So we want to cancel the moles of Br2 and find the grams of Br2. And that gives us, oh, we just figured that out, is 159.8. 159.8 grams of Br2 per 1 mole. 33 divided by 6.02E23 times 159.8 equals 8.7598 times 10 to the negative 21 grams. She is not here. How many sig figs should we have in our answer? How many sig figs in 33 molecules? Is that a countable number? Oh, yeah. That's a countable number. And if it's a countable number, how many sig figs? That would be infinite sig figs. How many in 6.02 times 10 to the 23? 3. How many in the 1 mole? That is infinite. We got 4. And how many in that 1 mole? Infinite. Okay, so that means we need, our smallest amount of sig figs is 3 sig figs, so we should round that to 8.76 times 10 to the negative 21 grams. And if you say to yourself, wow, that's a really small mass, well, what are you measuring the mass of? 33 molecules, which is a really small amount of stuff, right? That's a teeny tiny amount of stuff. Okay. Any other questions?
Oh, do you go add like that BR2 at the end?
Oh, I should probably.
Like that.
Yeah. Pardon me? Why is it Br2? Because bromine is one of the diatomic elements. Do you remember the diatomic elements? Yeah? So it says molecules of bromine. If it said atoms of bromine, that would mean that we would have Br, just a single atom. But if we have molecules of bromine, that means it's Br2. Yes, yes? Okay, cool, good question. Nobody did 3.2F? Well, if you didn't, make sure you do it before tomorrow, because at least 2 of the 5 questions involve like 3-step conversions. And you'll need to be able to do those. But they still involve only those 4 conversion factors. Yes, Rajan. You do not get the yellow sheet. Nope. The yellow sheet is a learning tool, but you can have the yellow sheet for a 10% discount on your mark. We'll call it a discount, okay? Yeah. So if you're really stuck, if you're like, I don't know what I'm going to do, you can use the yellow sheet for subtracting 10% off your mark. Okay? All right. So if nobody has any questions on that, let us remind ourselves about concentration. So you might just want a piece of paper for this, because we're just going to jot down a few things to remind ourselves, because it's been all weekend and we didn't do any homework on it. Concentration. Tell your partner, what are the units? What's one unit we can use for concentration? We can do moles. Whoops, why does my M have 3 bumps in it? Because I got a little overly carried away there. Moles per liter. Or what's the other way to write it? Capital M. How do we pronounce that? We pronounce that molar. And we can call the concentration, this kind of concentration with these units, we can call it the something, something. The molar concentration. Yes. What is the other word that we can use for molar concentration? Molarity. Okay, so the units of molar concentration and the units of molarity, because molar concentration and molarity are the same thing, are moles per liter, or M. What are 2 ways of writing concentration of Na2SO4?
Square brackets.
Square brackets. Na2SO4.
The little c.
The little c. And what would we do with the Na2SO4? Make it a subscript. Na2SO4. That's a little c. What is the formula to find? Why did I put tof int to find concentration? Ooh, look at that. I just abbreviated concentration by using square brackets, because that means concentration. What is the formula to find concentration? We can say concentration of Na2SO4 is equal to M.
Oh, wait, what?
There's two ways to write it.
Really here.
Moles over liter. So we have moles of Na2SO4 per liter. Now, is that liter of solvent or solution? It is liters of solution. Yes. Okay. You don't have to write all of that in there if you're actually writing the formula, but there you go. And what's the other way we could write the formula? C is equal to, yes, N over V. What does N stand for? Number of moles. Yes? What does V stand for? Volume of solution in liters. And if you haven't picked up on it yet, what is my abbreviation for solution? SOL with a little n. What's my abbreviation for concentration? Conc with a little n. Okay? All right. So finding it is really easy. Just remember, when you're finding concentration, it is a division, not a conversion. Division, right? Dividing by, not conversion. All right. That being said, we can actually use molarity as a conversion factor. So to find molarity, you do a division, but we can use molarity as a conversion factor. And if we learn this today, I realize we can't make the solution today because we need to be able to use molarity as a conversion factor first. So let's go to 5.3c, B, which is on page 59. So here we are. We're going to use molarity as a conversion factor. And because we want to convert between, what will it allow us to convert between? It'll allow us to convert between moles and liters. So now we have a fifth conversion factor, but that fifth conversion factor will not be on tomorrow's quiz. Okay? So no molarity on tomorrow's quiz. When we're using molarity as a conversion factor, you never want to write it as just capital M. You're going to always change it to moles over liters so that you can convert between moles and liters. And you're always going to rewrite your milliliters as liters, and you can just move your decimal place 3 places to the left to convert. So let's try an example here. In fact, let me see. This is all written down for you, but I'm going to grab it and pop it over to the side so that you can follow along here without seeing it. Okay. Ooh, so big. So here's the information we are given in the question. We want to know how many moles of NaCl. We are told that our volume is 600 milliliters. And we know that our concentration of NaCl, remember that's how we write it, square brackets, is 1.55 molar. If I want to convert between milliliters and moles, I should be changing my milliliters into what? Liters. Good. And how many places do we move our decimal? 3. To the left or to the right? To the left. We want to make the number smaller. 1, 2, 3. So that's going to become 0.600 liters. How should I be writing molarity? Should I be writing it as capital M molar? Or should I be writing it as 1.55 moles over liters? I'm going to write it this way because now this is a conversion. Oopsie. Factor. So I'm starting with liters. I want to find moles. Isn't it convenient? I have a conversion factor that goes between moles and liters. So all I need to do, this is just going to be a one-step problem. I'm going to say how many moles of NaCl are present in 600 milliliters, except for I'm going to write it as 0.600 liters. 0.600 liters of a 1.55 mole per liter solution. Do you know what's awesome? Do you know what the word of means mathematically? Of means times. And look what I did. I took my 600 milliliters, except for I changed it to liters. And then what did I do with it? I multiplied it of 1.55 molar. Isn't that nice? So the question actually tells you exactly what to do. It says, take 600 milliliters and multiply it by 1.55 molar. The only thing is you need to make sure you're in liters and you've written it as moles per liter first. But this is a beautiful thing about molarity problems is you can often solve them this way. It's really nice because it literally tells you multiply 600 milliliters by 1.55 molar because of means times. At any rate, we do that. We get 0.6 times 1.55 equals, and we get 0.93. What's the only unit we have left? Moles. Is that a good answer? No. Yes. Yeah, I need to have correct significant figures. What should it be? Three sig figs and 3 sig figs. So I need to have 0.930 moles, and I should probably write NaCl just to be, complete about it. How was that? Nice? Okay. And that's all there for you. How many, oh, what have I done here? Sucrose. Sucrose. Do you guys think you could do this one like without looking at the answer? So get yourself a piece of paper or whatever. And I don't know why I wrote KBR, and then in my answer key I wrote sucrose, but we're going to make it sucrose. Give it a try, just on a piece of paper somewhere. Oh, yeah. Did you get 0.038 moles? Or are we still working on it? Is good? Okay. And let's go the other way. So we're now on page 60. What volume? So if we're asked what volume, what unit are we looking for? Volume is measured in liters. How many liters? What should I do with this 1.25 molar? I assume you all know what you're doing and you're just working ahead. Is that correct? Or are we playing on our phone?
Can I use the washroom this time?
You can use the washroom. How should we write 1.25 molar? We should write it as 1.25 moles over liters. And we know that we have 5.0 moles. We can convert between moles and liters if we have moles per liter. So all we'll do is we'll say, I don't know how many liters I have. I am starting with 5.0 moles. What unit do we need to cancel? We need to cancel moles. And where does the liters go? Liters go on the top. Now, this is the one place. Do you remember I said the one goes with the mole? Not for molarity, because it's moles per 1 liter. Okay? So the one does not go with the moles for molarity. Okay, and if you have written it out like this, it should be pretty darn obvious that the number in front of the mole is not the number 1, right? So you would go and you would say, what number is in front of the mole? It is 1.25, and there's nothing in front of the liters, which means that is the number 1. So we have 5 divided by 1.25 is 4. The moles cancel out, and we are left with liters. Are we happy with the significant figures? 5.0 has 2 sig figs. 1.25 has 3 sig figs, so we need to add another 0.0 liters. And one more example. Try this one on your own. Okay. How many milliliters of 3.0 molar NaOH can be prepared from 0.15 moles of NaOH? Give that a try. Hi. So remember, you want to rewrite that as moles over liters, right? And M stands for meter, so you want MOL. There you go, MOL. There you go, moles over liters. Now, how are you going to cancel your units so you end up with liters on the top? Do you want it this way or do you want it that way? Okay. Now you want to get rid of the moles, so you put moles on the bottom and these go on the way. And you have 0.15 minutes. Yeah. Yeah. Thank you. Now, a couple of things that are going to make your life easier here. Firstly, what should we write 3.0 molar as? 3.0 moles over liters. The second thing that's going to make your life easier is if you say, I don't know how many milliliters I need, but this is your conversion factor. Molarity is the conversion factor. You are going to write it second. Woo, what happened there? Okay, this is your conversion factor. You're going to write it second. You don't have to. I'll show you in a minute. You don't have to. But most of you are used to seeing something like this. 0.15 moles and then times a conversion factor, yes? Can I leave that conversion factor the way it is? Can I write 3.0 moles per liter? Is that a happy thing or is that a sad thing? What unit would I get if I wrote it this way? I get moles squared over liters. So that's no good. I cannot have moles squared over liters. What on earth is that? So I need to make sure that my moles go on the bottom and my liters go on the top. And I have 1 liter and I have 3.0 moles. So you'll notice we wrote the conversion factor, the molarity, we wrote it second. 0.15 times, 0.15 divided by 3 equals 0.05. And I need 2 sig figs, and the unit I am left with is liters. Now I'm asked for how many milliliters. You are allowed to convert that, like by doing the conversion, or you can say, I want to move my decimal place 1, 2, 3 places to the right. Why am I writing 0.05? 50. 50, and to have 2 sig figs, I need to put a dot there, milliliters. Would it be okay to start by writing 1 liter over 3.0 moles? Yes, it would be. You could write it that way, but most people don't. What the place most people are going to go wrong is they're going to say, I don't know how many milliliters, and I want to start with 3.0 moles per liter. If you start with 3.0 moles per liter, where are your liters? Your liters are on the bottom. Where do you want your liters? On the top. So if you start with the molarity to do your conversion, this is an easy mistake to make. You won't realize that you need to write it upside down. Yes? That's why I suggest that you write the molarity second. That way you know whether to write it right side up or upside down based on what you are converting. Does that make sense? And if it doesn't make sense, come and see me during Flex and we can do a little practice. But not on Wednesday because I'm not available this Wednesday during Flex. Okay, but I'm available tomorrow. Okay? All right. So, for now, what you're going to do is you are going to do a wee bit of practice. You can do numbers, page 59 to 61. Numbers 1 through 6. And if you finish that and you would like to get ahead on the homework that will be assigned after tomorrow's quiz, I will write that up here also. If you've not done any of 5.2F, I suggest you do some of that in preparation for tomorrow's quiz. The whole thing would be better. Yeah. Yes. Yes. Pardon me? 5.1, yes. Let's just see what I got here. If you haven't done 5.1K, do all of 5.1K. Have you done 5.1K? Yes. In that case, you know what? Honestly, like this really actually takes into, like it works with those because what you're doing is you're going from grams to moles to molecules to particles. Or you're going from particles A to particles B to moles of B to grams of B. So, yeah. Plus, there's the stuff in 5.6A, the megamole review. Yeah, pages 91 to 93. Yeah.
You don't have to unless it specifies. So if it doesn't say, it is after the step. Yeah. Phones. Yeah. Um. Yeah. I thought that some fans are like, I've seen them before. I wish I had.
Yeah, five, 6. But we do.
Or this one. Yeah. 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 Right. Yeah. 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 Oh, so you're a pastor? So first of all, you're a pastor, you take something, and it's that you might start your middle school. Yes. Well, yeah, yeah. Yeah.
And if you're bored, You can always work ahead on 5.3c. You actually know how to do everything here now. You're just adding in that one extra conversion factor. Okay, so if you're like, I'm done, I'm bored, 5.3c, okay? Oh, is there anyone interested in the enriched stuff for this unit, which is finding empirical and molecular formulas? Would anyone like that? 1 person, 2, 3, 4. Okay, I'll make 10, because usually when I make one, not 5, I can just make 10. Stop recording.